Hi Sudarshan, can you hear me? Hello. Can you confirm that you can hear me? We will wait for 2 or 3 minutes, then we will start. Hello, Rajesh, can you hear me? Okay, now we can start. So, uh, we have so as we already know that we have already talked about string, list, tuple, dictionary in Python, and we have also talked about uh, uh, matplotlib and numpy in Python. So, today we are going to talk about NLTK library, and then there is uh, we will also talk about imaging library in Python. These two things that we are going to use today. And with this, uh, there, there is one more thing that is called that uh, so where you make nodes. So there is one more library that we will talk about. So before going to that, I want to get our basics clear. So that's why my first question is, what are different methods available in Python for generating a string? So options are A, by using single quotes. Option B is by using double quotes. Option C is by using triple quotes. And option D, all of the above.
Your option D.
Yeah, okay. So yes, we can create a string using single quotes, double quotes, and triple quotes. So using triple quote, actually you can create a string of in multi-line, right? So and you also use it to comment in like do for doing a multi-line comment. So what's the difference? How when it is used that triple quote string when it is used uh, as a thing for doing multi-line comment, or when it can be used as a string. So let us see here. So let us say I have a string, so I can define this is a string. So it's a it's inside a single quote. As I print type X, so it will print class str. Similar way, I can print Y. This is also a string. I can then print type Y. So for the first one is for the type X and the second one is a type. So it's for Y. So both are strings. Now we can also do something like this. This is a string with triple quote. Okay. Now we can print G type of G, and yes, it's also a string. What happens when we do not assign this? Okay. Uh, so we we can also do, if we try to write for, let's say for example in double quote, so if we try to write something in next line, let's say hello, so you are saying, you can see it's giving us error. Okay, this one, the second one, because you see this color changes, this hello string is no longer red, means it's no longer being treat so hello string is no longer being treated as a string because it's inside a inside a double quote. So you have to write whatever there in the single quote and in a one line. But if you try to do this with a string with triple quotes, then you can do it very easily. So it will no longer give you error, and it will uh, still, it is still a string, but it's a multi-line. It's a string in uh, more than one line. Okay. But if you remove this, let's say if you are not assigning this string to any variable, then it is just, it will be just treated as a comment, and so it will be ignored while executing by Python. Okay. So does anybody have any doubt in this first question? I'm sorry. Okay, if not, so let's move on to our next question. So yes, the option D, all of the above is correct. Now let's go to our question number two. And the question is, what is the output of the following code? Paragraph is, I am to go to Katie in A. And then I have written print list, and I have passed an argument to the list, and that is para. So which one of the following option is correct? Option A, I separated by space, then am, then space, then two, then space, then go, then space, then two, then space, then KT, then space, then in, then space, then A. Second is all the elements are, all the uh, things are separated. I, space, A, M, all these things are have been separated. Third one is that only characters that are separated by space are separated here. And the fourth one is that no space, but all the character in this list has been separated. So which one will be correct?
Then option B.
Option which? D.
B.
B. Can you write it down in comments? Okay, yeah. So option B will be correct because uh, all the things that are inside this variable, this para variable, has been passed as an argument to the list function, and what it does, it takes each element from this para and makes it into and saves it into a list that are separated by a comma. So we can see this very easily. So let's say you have some variable that is a string, and that is nothing but hello, I am going home. So let's say, uh-huh, okay, somebody wants to join. So now what I will do, okay, let so first something I want to show you. Uh, the thing is that for each in string, I as string is a iterable, so you can iterate through it. So I'm using a for loop. Now print each. Okay. So you can see each things each letters that are in this string has been printed, including this full stop and spaces. Okay. So and you can also print their index. So we know that in Python index start from 0. So whatever that is coming, that is being printed can be printed here also. So let's say we will increase the value of I by I plus 1 each time. So with the later you can you know that it's coming at 0 position, then it's at 1, then at 2, then at 3, then at 4, then at 5 we have space. So yes, 0, 1, 2, 3, and then 4, and then space at fifth position. Now, so this is something that yes, we can iterate through each element of a string. Now, if it is possible, can we change this string to a list? Okay, so let's do one thing. Let's make a list lt, and that is nothing but list of argument that is a string, and let us also print our list. So this is HELLO, I am going home has been printed. Now see here that there are 22 elements in this sentence in this string. So let us do one more thing. Let us print the length of this LT, that the string that the list that we have made. So let us print this. Let us do both. Okay, so here are 22 elements, including 0 to 21. Now here you can see here list has been made using the string, and its length is also 22. Okay, so this is something that can be done using a string, and if you use list function, so spaces are also going to be
Oh, yeah,
included. What?
string, sir, string.
Oh, so, oh, sorry guys, you could just reminded me. So earlier I was not sharing this screen. Okay, so I think I when I written this string hello I'm going home, from here you guys have not been able to see this, right? Okay, so I will uh, go through it again. So what is this? We have written it's a string. Hello, I'm going home. Now what I wanted to show you that you can iterate through the string. So and you can do it using a for loop. So what we are doing, we are saying that in a string, for each in a string. So there are like H, E, L, L, O, all these alphabets that are there. So they will be stored in each, and then we will print the each. So what happens? We actually get all the alphabets that are there in this string. And we also get the spaces. So all the elements that are there in this string are are being printed. Now what I'm saying that because this string is iterable, we can uh, also print the number. So that means the index at which position the element is present. So with this, we can also print this. So at zeroth index, H is present. At the first index, E is present, and the same way. Now, if so, we can okay. If we want to make a list from the element of this string, so we could easily return okay, make an empty list. Then what you do? You go to this list dot append, the simple append function, and append each. Okay, and now okay, we have appended each, and now what we can do? We can print the list. So here you see HELLO space I space M space going. So all these things is here, right? And the index that is starting of this H is 0, and then E comes at index 1, and so on. So what I'm saying is you can make a list using this method. So where you have to use a for loop, and then you append each element uh, using append function in the empty list. But there is also a another way. So let us make LT2 list 2, and that is made using a list function, and you have to just pass the string. So as an argument. Now let us print the L2, LT2, and now what happens? First, the strings element are printed, then this LT1 is being printed. So let us write it actually. LT, LT, and this is nothing but L, sorry, LT2, and then comma. Okay, now it has been printed. So here you can see there is LT, then there is LT2. Okay, and both of them are giving the same list. So so you can either use a for loop, or you can use just a list function to make a string out of a list. Okay. Does anybody have any doubt in this one, or any questions? No.
No, sir.
Okay. So let us move to our next question. So yes, the option B is correct here. Now let us move to our next question. That is that we have written a sentence that 8 o'clock on Thursday morning, Arthur didn't feel very good. Now I'm using words equal to sentence dot split, and I'm splitting the sentence where there is a space. Now I'm printing the word variable. So which of the following option will be correct?
Option
Option
A.
okay. Okay, so let us see this which will be correct. So because this split functions actually split the string at uh, at the positions where there is a space. So we see that at this position, after at there is a space, then 8 there is a space, then O clock there is no space in between. So this is O clock a one word. Then there is a space between o'clock and on. Then there is a space between on and Thursday. And then there is a space between Thursday morning. Okay, so we see that it is splitting at the positions where there is a space present. So at comma 8 and o'clock and on and Thursday, then morning, Arthur didn't feel very good. So this will be the correct answer. So the first one is the right answer. Now, why I'm trying to use this split function, it will be very clear in a bit. So I'm trying to motivate you, like if you have a string, if you have a string and you want to do something, some analysis of that string. So how many ways you can process the values that are present inside a string? So first one was okay. First one was how to make a string, then how to make a list of the values that are there from the string. Then next one was how to maybe split it at words that are separated by a comma. So all these things are like saying tending to something. It is saying like we are processing the string according to our convenience. So I also want to show you one more use of this split function. So let us say you have a string that is separated by comma, that is not separated by space, that is separated by comma. So let's say hello, comma, I am going home because tomorrow is holy. Okay, so tomorrow, because tomorrow, whatever. Now I'm making a uh, sentence and I'm using string dot split and the positions are where this is separated by comma. Now print the sentence. So here you see this string dot split has made a list and that is stored in a sentence, and when we print the sentence we find so where there were comma the string has been broken from that place, from that place only. So this is one more use of split function. So you can define your own kind of identifier. So from where it can be broken. So here you can see I have put my identifier as this star, and then the string has been broken from that place. So if it scan for star at which place they are present, and it will break from there. Okay. So keep this in mind. Now we will go to our next question, and that is before going to that, we should know that NLTK library in Python. So actually, it NLTK is a leading platform for building Python programs to work with human language data. So human language data is our this all the text that we write in books or whatever that we use. All these things are there. So if we want to perform an analysis you on this data, so there is a library. This is an NLTK library. So it's very easy to use, and it has over 50 corpora and Lexel resources such as WordNet, along with suite of text for processing library, classification, tokenization, stemming, tagging, parsing, and semantic reasoning. So it's a natural language processing library, and it has active discussion forum. So this sentence I have copied from this NLTK library website, so I can show you. So here for more information, so you can go here and read about NLTK. So it's a natural language toolkit, and it has a lot of things with it. Like you can have uh, what we can say. You can have tokenization, and so you can tokenize your your uh, your data, and then and so on. There are lot more things to do. You can tag your data, so it actually tags your data depending on which kind of uh, figure of speech is that. Okay, so now let's go to our next question. So here here I'm importing an NLTK library, and then I have a sentence that is at 8 o'clock on Thursday morning. Arthur didn't feel very good. Now I have tokenized my data, so nltk.word tokenize, and then I have a sentence that 8 o'clock on Thursday morning, Arthur didn't feel good. Now, once I run this command print token, so what is the expected output that you guys know?
Option D.
Option B.
D.
Yeah, option B. Okay. So, and why you think like it will be that? So let us see this. What will be the output? Okay. So it's so let's say I have a string. Let us first import NLTK. NLTK, and then there is a sentence. That sentence is at 8 o'clock on Thursday morning. Arthur didn't feel very. So our sentence is inside triple quotes at 8 EI. Sorry, for in the sentence. Okay, one second. So we have this sentence, right? Okay. Okay, now what we will do? We will tokenize our data to tokens and then NLTK dot word tokenize and, and then we are going to print token. Okay, there is an error, but this error won't be there in your local machines. So we have to use NLTK downloader. Oh no, so we have to import these two things together. So because I'm using this Google Collaboratory, so I have to specifically download this Punkt library from NLTK. So NLTK. Uh, so here you can see the answer is at 8 o'clock on Thursday morning. Arthur, then here it is did, and here it is not. Feel very good, and then there is this uh, end. So it is separating the sentence where there is a space, just like the split function. But it also did separate here, didn't feel very good. So it separated did at different position and not at different position. So that's why it's so NLTK. So I that's why I showed you this split function before. But so that's why it is different. So this option, okay. So option D is correct because you can see here at 8 o'clock on Thursday morning, Arthur did it separated and and she is also separated and then feel very good. So these are separated. Now what you can do with this data, you can actually so I think you can also do this uh, okay. Where is So once you tokenize your data, you can also do this tagging, I think. So you can so here it will be tag. Think it will be NLTK dot tag tokens print tag. No, no, it- So we can okay. So I will share this tab. So here what we have we have a sentence where at 8 o'clock on Thursday morning, Arthur did not feel very good. So first we have tokenized our sentence. So what does tokenizing means? It means like things. So the first one, it means like it is separating all the words and they are grammatically correct, right? Because here you can see did and not. They are separated. Uh, okay. Now, now next thing is once you have tokenized your data, so it's returning a list. Okay. So this is list of strings separated by a comma. Now, once you have tokenized your data, what you can do, you can tag it, and there is a module built in this NLTK library that is position post underscore tag. What it does, you put a tokenized data, so it takes that data as an input, and it says uh, what kind of value is the what kind of value is the string. So at is a preposition, eight is a common eight is a means a common so you have to search for the full form of these things. So 8 o'clock is a like NN means noun. Again, on is also a proposition, and it's Thursday is a neutral. I think pronoun, and similarly this morning is noun, and Arthur is also neutral pronoun. I think, and this is a did is a helping verb. So BBD, and not is a also a verb. So feel is also a verb, and very is also a verb. So it's a helping verb. And good is a adjective. So adjective is JJ. And then dot is full stop is a full stop. So you can tokenize uh, you can take a string, tokenize it, and then you pass that token to a tag behavior in NLTK, and it will give you the corresponding things like this preposition. What kind of words are they? So it can be easily checked with this assigned. It can be easily assigned with position tag. Okay. So now I have a next question. So that question is related to which of the following is not true about stylometry analysis. So it is saying that it is a quantitative study of literature style. It is based on the observation that the authors tend to write in a relatively consistent and recognizable ways. Any two people may have the same vocabulary. It is a tool to study a variety of questions involving style of writing. So, so which option should be correct? So, what we do in stylometry analysis, so it's the quantitative study of literature style. That is for sure. And B is it is based on the observation that the authors tend to write in a relatively consistent and recognizable way. So that is also correct. It is a tool to study a variety of questions involving style of writing. Yes, that is correct. So any two people may have the same vocabulary. So this thing is not right. So the C option is not right. So it is saying that so if the authors have their own writing style, so they should not have the same vocabulary. Otherwise, their writing style won't be distinguishable from one another. So this is what we do in stylometry. Now, next question is how we can identify which book is written by which author. So first option is by matching handwriting. by analyzing word length distribution with previous books, by analyzing number of pages in book, by analyzing book preface. So it's kind of a very easy question. So as you have already seen all the lectures, so you might know the answer as well. So what is the guess which option will be correct? That okay. So let's say I am giving you some part of that book. How you can identify it then? Which other option? Which writer have written it? Yes. So for this, we do this analysis using word length distribution, as it has been done in previous books. So that is called by analyzing word length distribution with previous book. Okay. So the correct answer is by analyzing word length distribution with previous books. Okay, now let us go checking on this. So you all must have seen the NPTEL lectures where the instructor has downloaded some files from the GitHub repository, and then he had performed some length length analysis of these words, and then he had plotted something. Then he had shown clearly that which literature has been written by whom, and based on that uh, gives gives which he gives his conclusion, like which is definitely written by this author, or it can be like a shared one, or it is not distinguishable at all. So let me go through it very quickly. So here I have so so I will share this Google Colab file with you. So on clicking this link, this link, you can easily find that GitHub repo. So this is the GitHub repo that you can find using this file, and then here you can stylometry.federalist.zip. So you can just here click on this download raw file, and it will start downloading. And because I have already done this, so once you unzip that file, so there will be a file called data. So, so there will be a file called data, and you can you can you can unzip that file, and so there are different file like this. So here you can see on the left hand side of this screen. So there is Federalist 1 txt. So these are txt files. So in these files, it's written Hamilton to the people of state of New York. So these are the letters that has been written. So it has been written on Saturday, October 27, 1787. After the unequal experience of the efficiency subsitting. So all these things are something written by Hamilton. Okay. So these are the online repository of the letters written by Hamilton. So, so what we have done, so I have imported analytical library, then I have downloaded, uh, so I have downloaded downloader, and then I have also downloaded the identifier, and then, okay, so I'm downloaded E, so L for list, so list. This is you don't have to do it in your console, I think, but here on Google you have to do. So it's just importing some modules. Okay. Okay, now all the third party packages, all these things has been downloaded in this NLTK. Okay, now what we will do, we will we are also downloading all these things. So here I have to do it manually, but in the like your local console, it can be done very easily. Okay, then I will. So these are the toolboxes that are being downloaded. Now, if I continue with this, so yeah, collections. So this collection, all the Karpura. So books, all the Karpura, all LLTK, popular test, third party. These things are being now downloaded. So now what we have to do, we have to install all these things. So just press enter and okay. I think now I have to quit. Okay. It is so now here you see I have created an dictionary. So the my keys are Madison, Hamilton, J, shared, and distributed. So there are three writers, as you must have seen in the lectures, and each have written different letters. So here the letter Federal 10. Okay, it has been written by Hamilton. Yeah. So no, it has been written by Madison. Okay, yeah. So it has been written by Madison. Then 14. Yeah, it had been written by Madison. Similarly, let's say check for 10, Madison. Let's for 11, so Hamilton. So whatever has been written by whom has been written inside a list. So these are authors and these are the letter number. Federal list as underscore 10. So that is the identifier here written. So all this the like this second one. So where is the second one? Federal list. So let's say for third one. So it has been written by a writer J. So like this, there are some shared letters that has been written by both Madison and Hamilton that are on 18, 90, 20 and 49, 50. All these are disputed, so they don't know which they have written. Now what we are doing, we are defining read files a function. So what it does, it has a empty string. But first it read files from the file name and then it joins whatever there inside the file and it saves in a string. Okay. So slash n means join the string with where the new line starts. So all the lines that are there in the your text, it will join them. So let me run it side by side. Okay, so it will a dictionary has been created papers. So a function has been defined. Now what we are doing, we have a federalist by author and this is empty string. So now we have authors comma files in papers dot items. So papers is here. Paper dot items means it will give the author name that are J shared distributed, and the files will be nothing but 10, 14 corresponding to each author. Now what will happen? So federalist by author will be this key and the corresponding value is this read files, comma files, and files are nothing but formatted file in file name, and this is has been given here. So that means this file is not this is a list, and from this list here it goes here, and then there is another for loop. So it takes out each value from this file name, and then it formats your txt file in this manner. So this file is a variable, but the federal list underscore dot txt is constant. So it keeps changing. That means it goes through each file of this, and then what it does is actually joins all the data that are related to medicine inside, and that data is stored in a string. Okay, that string, and the string is returned, and then here, so something like this happens. So here happens like this here in medicine is stored here, and then you have the value, and the value is nothing but all the data in the files or in the letters that are written by uh, this author. Okay, so all the data comes here. Now what happens? If all the things have been here, so let's store the data also. Data has been stored. Now we have defined a tuple, and we have defined the author token, then length distribution. So what we do, we tokenize our data based on the authors. So for that, we use this word tokenizer, and for that we have to download this package. So we do that, and then for authors in author, nltk.word tokenize filter federal list by author. So that means this key is given, and now tokens are generated. Then what happens? For token in the tokens, so the tokens has been generated like we have like I have shown you how the token are generated. So here you see this type of tokenization has been done. Okay, so it is done. Now what happens? Once the tokenization is done, so you go through each token of that tokens list, and you check for each alpha. Means it, it is checking for each alpha, and then what happens? Okay, so and it is stored in a tuple. Now from here, so in this author token, so what happens? It takes the length of that token for each author, and then what happens? It is stored for like each tokens. The length is stored, and those length is plotted with the samples. Okay, so sample is giving here like how many samples you want. So 15 samples we want, and so this is stored. Now let's run this. So it's a frequency distribution that we plot for these token lengths, and we are only plotting for 15. So once I run this, so here you see, so it is only plotting the disputed. So, but I can plot all the data. So for author in authors, so authors is here Hamilton and Madison J share disputed in this order. So I will use a for loop to go through it. So I gone through the data. So here length distribution is here. So you see Hamilton is a 350, uh, and then Madison it's 350. Okay, something. Okay, so plotting the same data because we have created an empty list. We have author tokens and then length distribution. These two are empty strings. Now what we are doing, we are going through all the authors and then we have this federal list by author, a dictionary. And once we pass the dictionary the key, so we get the corresponding value. Now, so this value is nothing but a string. And once you passed word a string in word tokenized function, so it gives the token. Now we have the token. So what we are doing, again, we are creating this because these lists are empty, these strings are empty. So we are giving a key and then we are storing a value. And that value is token. Okay, here we have to token. So we are using a for loop in so for for token in tokens. So whatever the token is coming here, if any C alpha, so you can so it checks for the uh, check for the alphabets in token, and if the alphabets are there, then it stores in them in a list. Okay. Then again, what happens? Then there is a token length, and we can understand that it's nothing but whatever the token length of that token for token in author tokens. And author tokens, it then again is just a value, and then the token is so each token from that value is taken, and the length corresponding length is stored inside this token length uh, distribution. Okay, so be this thing has to go here inside this one. So now what will happen? Okay, we are giving all the tuple values, so it should plot all the values, but it is failing to do so. No, it is wrong here because in the first case where we pass the authors tuple to the length distribution, so because we have already this token length, Maybe we can run this inside this loop. Okay. Uh, so we are getting some error, but okay, now it's correct. So the problem was that so uh, these two were empty because these two things were outside of this loop. So the corresponding length were not being appended to this author tokens. So here we can see as Hamilton, samples are 15 and the word count according to that. So the word that has length of 2 is 350 and then it is decreasing in some fashion. Now we go for Madison, so it's around 600 and then it start to decrease in this fashion. And for J, it's kind of a step like, okay? But now let's compare the shared. So that are shared by Hamilton and the Madison. So you can see the shared one is much more 500 words are there at 3 than at 2, all these things. So we can see from this Madison and from this Hamilton sample that uh, Okay, so we can see from here. So that shared one is much more contributed by this Madison guy because you can see the trend is same. Okay, and similar way in the disputed one we don't know because you can see the J has also nearly the same trend and also this Hamilton is also having the same trend. So yes, the dispute is different, and this way you can identify who has written what later. Okay, so does anybody have any other doubt? Obviously, so- Hello. Sir, when I opening the GitHub link, it is showing page not found error. Can you provide the correct link? Sir, what type of question do you generally comes in the NPTEL exams, or like only MCQs? I think the programming questions also comes in NPTEL exam, if I'm not mistaken. So let me first share the link with you in the comments. So I found the link for you guys, and I'm sharing in the comments. Okay, and so Bitika Saab, so I think this MCQ and also the written exams are like coding exams also comes. So does anybody have any question in this one, like what we are doing? So you understand tokenization. You also understand if you have a tokenization is nothing. It's just you are breaking that entire string in small words, and you are putting in a list. Now each element of that list has some length, and you are counting that length, and you are putting it in a different length. Now different list. Now what are you doing from that list? You are giving it to the internal function, and that function is nothing but frequency distribution. So, so what it does, so it frequency dist is what actually it does. It counts how many times something has appeared, and then for that that value is plotted. So in this way, like this length two has been come 350 times. So for two, 350. For 3, it's 150 times. For 4, it's 60 times. So all this you can see nice a trend for any writer, and this is what we are comparing for different writers. Does anybody have any other question? Okay, if not so, then we can move on to the next question. So the next question is the network X in Python is used for which of the following operations? The options are visualizing social network, analyzing social network, generate social network, all of the above, none of them. So you can write your answers in the comment in the chat box. Okay. So because this network X in Python, so it's a library. So what it does, it actually it kinds of, let's say you must have seen the NPTEL lecture where the instructor talk about stations that are connected, and then let's say there are major stations in different cities. Now, if you want to go from a city uh, to another city, then you will look for a direct train. If it is not possible, then you will look for a connecting train. So there you will have to go station A, then C, then station B. If there is no train available between station A and B, so that is also a network. So what it does is this network X library, it's actually used to visualize the this kind of connections that are there between different nodes. Okay, so you can visualize the social network, analyze the social network based on the like how many connections are there, which kind of which is the shortest connection, which is the longest, all these things, and then you can generate also the connections using this network. So the all of the above are correct here. Now the question number 8. Which of the following will generate a complete graph in Python using network X package? So I have one question that in NPTEL exam is there a negative marking? Okay. So if this is the doubt, maybe we can go on the NPTEL portal itself. Okay, so let's go to our code and then go to the code. And so what are the things here? So the certificate and all these things. So here is that registration. Then here you have like average of assignment is 25% based on the best 8 assignment of your 12 assignment. Then exam score is 75% out of 100. And then final score is your this. And okay, 30th. So this is the policy, their policy. Now about the course. So what kind of so maybe you can ask this question to the on the discussion forum. Okay, so maybe you can ask the question here whether there is going to be the um, uh, like assign exams based on the coding problem or not. I'm not familiar whether there is going to be a coding problem or not. Okay, and also about this negative marking. Okay, so the next question is uh, so all of the above is correct for this network X in Python. Now let's go to our next question. So here we are. Okay, first let me introduce you to the network X in Python. So it's nothing but a so what we have to do, we have to import network X as NX. So I'm importing a package that you don't know about as NX. Then what I'm doing, I'm plotting a graph using NX dot graph module. and I'm giving it a name G. Okay, I have just done that. Now, if I try to what nx dot draw, so what will happen? Nx dot draw. So and it's a library in the network app. And now you have to give the variable name what you want to draw. And then you click OK, and there is nothing because you just have created a graph and you haven't given it anything. So that's why there is nothing. Now let's say we add a node 1, then draw it. Okay. So let's say we have added a node and then we are drawing it. So one node is created and it has been drawn. Okay. Now what happens if I add another node? Let's say 2 and 3. So there are three nodes are created, but they are not connected. Now how we can connect? So you can also get the information using print. So if you use print, so G, so it will give you information that graph with zero nodes and zero edges. Okay, and here you can print out this. So print G. So here what happens? Graph with three nodes but zero edges because we haven't created the edge yet. Okay. Now how we can create the edge? So there is a built-in function, and that built-in function is edge 1 and 2. So that means we are connected. So let's say this is 1, this is 2, this is 3. So node 1, node 2, node 3. So node 1 to 2, 2 to 3, and 3 to 1. So we can have three edges. And how to give them in this graph? So you do this g dot add edge, and then you tell about the node 1 and 2. Then to node 2 separated by comma 3, and then and so on. And so once you run this and then you print, oh, what happened to my graph, then you will have graph with three nodes, three edges. Okay. Now if you draw this, if you draw this nx dot draw, so you have G and then you are doing this. So you see these are the edges that are now there. Let's say you don't have this edge now. You have that. Okay, no, we have to create that object again. G is equal to nx dot graph. So it visualizes the distribution. Now what I have done, I have only told that only connect the edges 1 and 2 and then 2 to 3. So what I found out that okay, graph with node 3 but two edges. Okay, because 1, 2 and 3 and there are only two edges. Now what you can do here, maybe you can remove this one and ask for it to connect 3 to 1, not the 2. So what will happen? So okay, because it's in different places, so it get stored. Let's put all them here. So what happens? Okay, maybe I also should include numbers. Huh? So you see, here is now you can see the node number, right? 3, 1, and 2. So what I've done, I've asked this graph. So I have assigned three nodes now, but I have only assigned two edges, and that was from 1 to 2 and 3 to 1. So you can see it's from 1 to 2 and 3 to 1. And let's say you had another node g dot add node 4. Oh, sorry, 4. Then what happens? Then you have a node 4 here separated because it has not been instructed to be connected with anyone. So that's why it's separated, but one is connected to 3 and one is connected to 2. And similarly, you can add also g dot add age 4 comma 1. So now what happened? A will come in, A will be connected with all the edges. Okay. But now you see like writing this, assigning the node and assigning the edges, like it's very tedious and boring. So what you can do instead of this, you can just you can so here you can see also g dot nodes. So it give you the nodes and g dot edges. It gives you the edges present in the graph. So there are four nodes, but three edges. One, two, three, three edges. And the edges are 1 to 2, 1 to 3, and 1 to 4. Okay. Now next we draw the G. So it has been drawn. Now nothing. We have to do nothing from it. Okay. Now there is another way, actually, to uh, assign nodes and assign the edges. So here you see when you printed G dot nodes and G dot edges, you got a list of nodes and a list of edges, and the element of this list were for nodes, it's just a number 1, 2, 3, 4, an integer number. But for edges, it was a combination of two numbers, and it was a tuple inside a list separated by a comma. So we can get some idea. Oh, if we want to do something like this, so we can uh, do a very similar thing, because we can pass a list and we can also pass another list, and that is for that is for nodes. Okay. And second list is for edges. So there is a function called g underscore nodes from, and you pass a list, and g add edges from, you pass a list that are there. Now once you draw this, so you will have your nodes and you will have your edges. Let's say you remove one element from here. So if you remove one element from here, so it is only the nodes, not the edges. Like two nodes, two edges, three nodes, right? And so now you have been familiarized with this. Now there is one more thing. So there is called something called random in this library, in this network X library. there is something called random. So there is a random module in the network X library. Sorry, guys. Uh, so what happens here? Where I was, so, okay. So here is this. So there is a random library. So you import network X as NX, then you create a graph. So it's the empty graph. Now, if what you do, you say you have a command gnp underscore random graph. Then you say the number of nodes, and you say the number of the probability of each node being connected to the different node. So here I have said that I have four nodes, and the probability of each node being connected to the different node is one. So what will happen here once you run this? So you will have one, two, three, four nodes, and each node is connected with another node by one probability one. Let's say what happens if I do this. If I remove the probability of each node being connected to other node by half. So you see, like, okay, so here one node is totally isolated, but others are connected, and these two end node are not also connected with each other, and these two are not connected with each other. So this is how a random graph works. So if you give the full probability, so it will actually connect all the edges, all the nodes. Let's say I have five nodes, so all the five will be connected like this. So each node will be connected with other four nodes. But if you lessen the probability, so it will be a bit random. Still, you can see at 0.75 probability, all the nodes are connected with other nodes. But it's not the case now. It's just very random because you see, if there are five nodes, so each node should be connected with four nodes. But for this one, there is only one, two, and three nodes. For this, there is four. For this, there is three. For this, there is one, two, and three, and four. There is four. For this, there is four. So it's a probability. It's not definite, but each a node can have all the four nodes. But the probability is that having nodes connected with other nodes is 0.75. So that's why some nodes have three nodes, some nodes have four nodes. Okay. And similar way, if you do this, so you even further reduce the probability. So maybe some nodes maybe get isolated. Yeah. So now the situation is worse. All the nodes are not connected. Some nodes are very separated from each other, and they are not connected. Okay. If you have understood this, then maybe you can answer my this question. So my question is, which of the following will generate a complete graph in Python using the network X package? So I have created a graph that is nx.gnp random graph, and I have given 25 nodes, and the probability I have given is 0.5. Then in B option, I have increased the probability to 1. Then I have again in C option decreased the probability to 0.25, and then in option D, I have decreased the probability to 0.75. But what I'm asking is a complete graph. So what is a complete graph? So complete graph is the graph where each node is connected with other node completely. So what do you think? Which option will be correct? Yes, because we have to now when the probability is one, that means it is sure that the one node will always be connected with other nodes, and that's why this is correct. Now I have a next question. So I'm asking a question: how many neighbors does node one have? So you see here is the node one. Here you have a node one. Okay, so here you have a node one, and it is connected from 3, it is connected from 0, and it is connected from 2. Now I'm asking how many neighbors does node 1 have? So what is the answer? Can somebody tell me? So what do you mean by neighbors? So neighbors are someone who are connected with so we call neighbors in, let's say, in very layman term. So beside your house there is another house, and if it just beside your house, so you call them neighbors, right? Means they are connected somehow with your house. So if I have one here and it is connected with 0, it is connected with 3 but not connected with 2. So what do you think? How many neighbors of node 1 have? Yeah, so Hefejiba, it's correct. He's saying it's B. So yes, it's two nodes has so node 1 have two neighbors, and that is correct. Okay. Now the next question is, so this is the area calculation. Before going to that, I want to show you one more thing in this network X graph. So what you can do, there is something called a complete graph. So it's nothing but you just create a graph using nx.graph. So first, let me say, show you. So you import network X as nx, and then what you do? Hmm. What is that? Okay. Where is oh network X as nx, and then you say g.nx, you create an empty graph. Then what you do, you say nx dot complete graph, and then you give the number of nodes. So it's 5, so will give you a 5 nodes. If it's 4, it will give you a 4 node, and it is complete because each node is connected with other node. Okay, you can also print the g dot nodes, and you can also slash in the new line. In the new line, you can also print the g dot edges. Okay, so you see the nodes are 0, 1 to 3, and the edges are 0 to 1, 0 to 2, 0 to 3, and then 1 to 2, 1 to 3, and 2 to 3. Means all the edges are connected now. Okay, if you do it like 5, so 5 should have like 20 edges, right? Uh, no, no, it should not have like 20 edges. It should have 5C1, then uh, okay, so what is the probability to calculate this? Like if we have 5, then it is connected to two nodes, so the unique combination that can be made is 5C2, right? And 2 into 1, that means 10. So it's 1, it's 2, 3, it's 4, 5, 6, 7, 8, 9, and 10. If it is 4, then it should be uh, 4 into 3, and that is 12 by 2, and that is 6. So it is 3 here and 3 here. So you know that combination rule, just a simple combination rule where you have number of nodes, and if each node is connected with other node, then there should be two unique element from the 5 element, and this would be connected to 5C2 or 4C2, all this kind of thing. You can also check it for 3, and that is nothing but 3C2 means 3 into uh, 3 into 2 divided by 2, and that's nothing but 3. So it is true for that. And if you go for 2, it will be just two nodes connected by 1. And if you go for one node, the, the, it's just a 0 because there is no edge. Okay, so this is how it works. This complete graph, you just put the number of nodes and you get something like this. So here are the edges and here are the nodes. Okay, now if it is complete, so you can also use this one to label the edges and the say I want to make something here. So I can make it here. Uh, I will do this. So import a pyplot hplt, then create our own graph with given number of nodes, then draw the graph. Uh, so then nx.string layout, it will give you the position of all nodes, and then you draw the position, the graph G with the labels on, and the font is bold. That means you will get something like 1 here. And once it is done, then age labels. So age labels must be the combinations with, so you format a string, then in G dot ages, and you have the string. Now draw this G, the position. The position is here where you have to draw, and the age labels is equal to age labels. So that's like so it. So it, I think it will be very happy. So 25. Oh my God. Let's reduce it to 5. So you see, it is going from 0 to 1, 0 to 3, 0 to 2, 0 to 4, and 1 to 3, 3 to 2, 3, and 0 to 3, all these things. So it's a very cool way to represent. Okay, now does anybody have any doubt in this one? Okay. Oh, okay, I was saying for this only for this thing, right? Complete graph. Okay, so from here the screen was not visible, right? So what I was doing, I was just using a function, built-in function that is complete graph, and I was giving some number, and I was then plotting it. So I was just plotting it. So nx dot draw and DRAW, just give the graph name. And what it was doing, it was plotting all the edges and nodes completely. So if you give it 5, so 1, 2, 3, 4, 5, and all the edges, all the nodes are connected with other edges. Similar way, you can have, let's say, 8, and here, so all the other edges are connected with other edges. So here, if you have three, it will be like this, and if you have four, so four will be like this. Now what we do? We put something here. So what we are doing? We are plotting the positions and the edges level for this. So you can see it's 0 connected by 0 to 2 and 0 to 3 and 0 to where is 1? 0 to 1. This is 0 to 1. Maybe again, and it is visible. So okay, it's drawing two times. There is some mistake. No, it's correct. So two is matching with 0 to 2, 2 to 3, and 1 to 2. And now 0 is matching with 0 to 2, 0 to 1, and 0 to 3 here. Okay. So similar way you can completely show any kind of number as a given node and their combinations. Okay. So here are the nodes and here is the combination like edges. So you can do it very easily. Now let's go to the area calculation. So if you have been through the lectures, so there is there it has been shown like you have to calculate area of Punjab region, and you know the area of India. So what you are doing there, you are just randomly putting you are generating a random number, a random coordinates, so to say, and if it is you are inside India, you are giving India count one, and if it was inside Punjab, you are giving Punjab count one. Then what you did, you taken out the ratio of counts occurring in Punjab and then counts occurring in India, and then you have just taken out the ratio of count inside the Punjab and count outside of the Punjab. That means in India, and you multiplied that with this ratio with the area of this area of India. Now, what you get in output was the area of Punjab. So this was one of the method to guess the area of Punjab. So while calculating, the question is while calculating the area of Punjab, which of the following will help in more accurate results? More points landed in Punjab region, more points landed outside the Punjab, more points on the overall map, none of the above. So what do you think which one will be correct? Guys, can you comment just a random guess? Let's take a random guess. Okay, A. So more points landed in Punjab region. Yes, so your guess is correct. So the more points it will land in Punjab region, the more it will be helpful to estimate the accurate result. Okay, with this, let's go for calculating and okay, so let's go to calculate. I have actually prepared something for you. So what I'm doing here. So so I have downloaded a map of India from this website mapchart.net india.html, and once I click on this, so here you can see you can create your your own state. You can select any state, and okay, and you can select any state. So let's say I've selected Rajasthan. So first let's clear all the things. I've selected Rajasthan, and then I don't want any borders. So border is gone. Now that's it. You can download the map, and map will be and the map will uh, look like something this. So okay. Yeah. So once you have downloaded the map, let me wait for a minute. Okay, so you may see my screen where I can where you can see. So I have this region, that is Rajasthan, and this is India's map. Now what I will do, I will because here is some another point. So let's crop that, and here is something written here. So let's crop it. Okay, and let's crop it and save it. Save as a copy, and now we have saved it. So this is what we have already. I have already done. So I'm not going to do that. You can do it now because I'm using Google Collaboratory. So I can upload that image here. So this is the map chart that I have already done. So I've uploaded it. So here you can see this map chart.png. It's here. Okay. So I have already uploaded that image map here. Okay. So you can see it in map chart. So here you can see the file map chart.png. So I've already uploaded that image. Now what I'm saying, so okay, this is for it. Now you can actually search for the RGB values. RGB online, my image. So you can go to this website, imagecolorpicker.com, and you can use your own image. So here what I'm using my own image, and that is this. Okay. Once you upload your image, so you can get the hex RGB values. So more options. It's a RGBA format, but we are not going to use that. So we are going to use, let's say, I'm clicking on show more. So it is taking some time. Oh, something happened. Let's go to again image picker. So this website is down, but what you can do, you can visit it and you can get your RGBA values. That's it. So that's the only use of this website. Now what I will do. So I have already taken out the RGBA values from this image. So for the Rajasthan region, the red one has this RGB values of 204, 51, 51. And Indian, this gray map has this value of 209, 219, and 221. So what I'm doing, I'm using Python image library and importing it as an image, and I'm importing random, and I'm importing NumPy, and I'm importing matplotlib.pyplot. Now what I have this image that is nothing but image.open, and then what I'm doing, I'm opening the image, and so let me do that. First, I imported the necessary library. Then I opened the image, and the image is here. My map chart map.png. So this is the my image. Now I will show the image using plt.imso. So it's a module in pyplot. So you can see this is the x value, this is the y value, and you can see very nice image. Now you can convert it the image using convert to RGB image. So once you did do it, it will be converted to RGB image. So each pixel will have now three color values. Now we get the size of this image using image dot size, and that returns a tuple, and that is so and that is that is stored in the variable x and y. So you see the variable x is 3818 means 0 to 3818 somewhere here, and the y variable is 4133 means this 4133. So 4133 from 0. So this is the y and this is the x. Okay, and y starts from 0 here and x start from 0 here. So 0 to this and 0 to this. It's a bit opposite to your Cartesian coordinate system. The y is very opposite, but this is the case, so we are not going to do anything. So now what we are doing, we are counting Rajasthan, counting India, and we have count 0. So we have defined a threshold because we are going to perform this experiment 100 times, and 100 times we are going to generate a random coordinate x and y. So you see the x coordinate is nothing but the x value of the image size. So 3818, and the y coordinate is nothing but the y value of the image size, that is 4133. Now we have this g is equal to image dot rgb get pixel x comma y. So it actually returns you a, a list of RGB value, and that are the so each pixel here in this image will have some value like one, just like I showed you here. So it will have some value like this. So that is the RGB value. Not now what I'm doing, I am I'm writing this one inside a, it's what it does. This actually returns a list. Now from that list, I'm taking the second value, means the value that is present at index 1. So you can see for our case, it's a 51 and 219. So for Rajasthan, it's 51. For India, it's a 219. So we are selecting that. So we are saying if G is equal to 219, that means the coordinate is in India. So increase the count for India. So once you are increasing the count for India, if it is it has this RGB the gray value of this. That's why I named it G. So gray value of 219. Else, if it has gray value of 51, the point is inside the Rajasthan, and increase the count of Rajasthan and also increase the count of our experiment. Okay. So once I run this image size, I get this. Now I run this one. So the experiment had been performed 100 times, sorry, 1,000 times. Now the area of India is 32 lakh 87,263, and this is the area of Rajasthan, 3 lakh 42,239 square kilometers. Okay, the formula is this: the area of Rajasthan should be equal to area of India multiplied by count of Rajasthan and divided by count in India. Okay, so once we run this, we have area of Rajasthan is equal to uh, 3,77,000 means 46 square kilometer. But the actual area is 3,42,239 square kilometer. So let us increase the sample value. Let us increase the values of count. So I make it 10,000. Okay, the experiment has been performed. Now we run it. Now what we have is here. It's a 37 lakh. Oh, sorry, 3,77,000. So let us increase it bit more. So let's say it 1 lakh times. We are generating random numbers and doing this. Now what will happen? It's very close actually to this 3,42,000. But we can run it once more. So it's this time this bit reduced. Now let's increase to 10 lakh. What will happen? So it's going to perform 10 lakh calculations. It is going to take some time. Okay, taking 13 seconds. It is improving. As you can see, it's a 3,78,000. It's improving. But if you want to get to exact value, you have to increase the count more. But this gives the approximate result around that value. Okay. If you do with 100 points, it's very bad. It's 2,82,000. So it's kind of probabilistic. That's why it's giving some estimate, the result in very proximity to the actual result. Okay. Does anybody have any doubt in this one? If not, so let's move on to our next question. And the next question is, which of the following is true about 6 degree of separation? So the minimum degree of separation for any node in network is 6. The maximum degree of separation for any node in network is 6. The average degree of separation of nodes in network is 6. The degree of separation of every node in network is 6. So degree of separation is the average nodes in any network. So actually it's the C option that is correct. So it's the average of separation for any node, and it is equal to 6. It's the average value. Okay. If does anybody have any question? Oh, sorry. So I should share this tab. So this was the question, and this is the answer. Does anybody have any question? Anywhere? So what I'm going to do, I'm going to share this YouTube link. I'm going to share this PPT in the description, and also I'm going to share the Colab notebook in the description. Along with that, I have given the important link in the Colab notebook itself, so you can find all the files that I've used in this video. And I will also put this image picker image picker. So from here I got the values of RGB values, so that you can later on access it and get the correct RGB value. Okay. Does anybody have any question? If not so, then I would like to acknowledge Professor Sudarshan Ainagar from IIT Ropar, NPTEL team, PMRF team, and Department of Physics, IIT Kanpur, for giving me such opportunity to uh, conduct this session. Okay, I will see you guys on next Saturday evening at the same time, 6 to 8 p.m. And I'm going to close this meeting. So happy Holi, everyone! In it, uh, and see you next time. Okay, bye. I'm going to close this meeting. Okay, thanks everyone. Bye. Happy Holi, happy Holi. Okay, bye bye.